Okay, everybody, good morning and welcome back. This is our Google Meet for Friday, 25th February, and in this class, my plan is I'm going to discuss the tutorial questions for Chapter 4, Biochem. And then if you have any questions, feel free to ask whether it's about the tutorial or about the concept or anything else. And if we have extra time, I'll talk a little bit more about the experiment I asked you to do yesterday. And maybe we'll have some announcements today. So we'll see. Everybody ready to get started?
Ready, Miss.
All right, thank you. Okay, so here is the tutorial questions. Okay, kali ini saya tidak buat itu objektif di Telegram sebab macam banyak benda saya mau letak di Telegram yang saya tidak mau tertanam. So I choose to do this week's objective in tutorial only. Kita tengok kalau ini berkesan untuk kamu lah. Okay, so I'll just give you the answers for this and then you tell me if you have any problems with it. Okay, so kita tengok bahagian A terus. Alright, so answers for chapter 4, objective A, 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 D, C, B, C, C, C. Hold on, 6, B, sorry. 6 is B, 5 is C. 5C, 6B, 7C, 8C, 9C, 10C. Those are the answers.
Miss, how about question 3?
Okay, hold on. Tutlah saya tu. Oh, okay. Oh, 3A, 3A. My gosh, I should go back to primary school. Okay, hold on. A, D, E, C, okay, those are the answers. You can mark yours. Do you have any questions? Why is this like this? Why is that like that? Kalau kamu ada sebarang soalan untuk bahagian objektif, boleh tanya sekarang. Any part that you're not quite sure, why is that your answer? Anybody have any questions? Okay, then I want to focus on on a few segments before I continue. Okay, I want to look at question number 5. Which of the following statements is not an effect of enzymes on biochemical reactions? Kenapa jawapan dia C? Bukankah enzyme break chemical bond? Anybody know? Kenapa C bukan effect enzyme on biochemical reaction? Okay, Lim answered in the chat, enzyme is catalyst. Alright, so Lim's reasoning is correct. Enzyme bukanlah benda yang pecahkan chemical bond. Enzyme cumalah benda yang mempercepatkan pemisahan chemical bond. So dia adalah catalyst. Kerja dia tolong saja, bukan dia yang kasih pecah. Correct? So remember always that enzymes are just catalysts. They don't do the work, they just help with the work. So yang betul adalah 1 dan 3, tapi sebab soalan minta not an effect. So jawapan adalah 2 dan 4. Okay. Any questions that have problems? For question number 8, which coenzymes involved in redox reactions? This one you have to remember the information from the slide lah. Ini lebih kepada ingat maklumat daripada ingat konsep. Okay. All right. So one last look. If you have any questions, feel free to ask. If not, we'll move on to part B. Okay. All right. Then we shall move on to part B since there are no questions. Kita terus kepada question number 1. The equation below shows the reaction of sucrose with enzyme X. So sucrose bila dia dalam reaction ini dia dicatalyze oleh enzyme X. Sucrose dipisahkan menjadi fructose dan alpha glucose. Now the first question is already a little bit tricky because it asks you to identify the enzyme X. For a lot of enzymes, if you are not sure, you can tembak and change the name of the substrate a little bit to guess the enzyme. So kalau amylose, contohnya, kalau amylose, dia akan jumpa enzim amylase. So you can simply try to change the ends of your substrate, and 90% of the time, you will get the enzyme's name. So kalau substrate kita adalah sucrose, kita tukar sedikit ejaan dia, kita boleh dapat enzyme sucrase. A lot of enzymes end with ASE, ACE. Okay, so for this one, memang the answer is sucrase. So if you answered that, you get 1 mark. Maybe you Googled it, maybe you just guessed. But if you ever see this in an exam and then you're really not sure, just try this technique. Cuba saja ubah ejaan dia. 90% of the time it works. And tidak payahlah saya tanya banyak pasal nama dia kan. It should be okay. And then moving on to question 1B. Would a similar reaction occur if enzyme X is replaced with other enzyme? Explain your answer. Somebody, please answer me. Rasanya reaction yang sama kah akan berlaku kalau kita tukar enzyme X dengan benda lain? Yes or no? Farhada, do you think it's a yes or a no? Oh, okay. All right, we've got answers in the chat. Intan and Shifa and Alice said no. And your answers are correct. You would not get a similar reaction. Why? You could answer with enzymes are specific to their reactions. As your answer, so that could get 1 mark. You could, okay, di sini skema jawapan saya menggunakan ayat yang formal sedikit. In my answer scheme, it says because active site of enzyme is specific towards specific substrate? Yes, Alice punya jawapan dalam chat pun betul. Enzyme has specific active sites. Of enzymes is specific towards specific substrates. Okay, this one is fairly simple, right? So I hope I don't need to explain this too much. But if you have problem with this, feel free to ask again later. And I move on to question 1C. Can enzyme X be used again to react? Oh, hold on, before I continue. Intan tanya dalam chat, what about substrates have its specific active site, miss? Is it the same? Okay, untuk soalan Intan, you cannot say substrate have specific active site. Active site itu adalah pada enzyme. Substrate ada shape, but enzyme yang ada specific active site. So, no, not the same. Good question though. Thank you. Any other questions about the 1B? All right. Okay, I'm moving on to 1C, okay? Can enzyme X be used again to react with another sucrose molecule after the reaction is completed? Explain your answer. Yes or no? Okay, we have some answers in the chat. Marnie, Farah, Alice have answered yes, and you're correct. Enzyme X can be used again. Explain your answer. You can say things like, oh, because enzymes are reusable or enzymes are not destroyed after every reaction. Those two are the main answers. And anything that is close to that, I think can be accepted lah. So you just write that enzymes are reusable. And done. Yes, satu markah, enzymes are reusable, satu markah. If you ever see questions like this during exam, tidak pandai explain pun enggak apa. Yang penting kamu pandai jawab yes atau no dulu. Okay, sekurang-kurangnya satu markah di sana. Alright, and any other answers that you want me to check for 1C? Okay, so 1C is all right. Then I'm gonna move on to 1D. Name one non-protein substance that enzyme X might need for catalytic reaction. Kalau kamu sudah pergi Google berhabis apa cofactor untuk sucrase, that's fine, you can put that in there. But if you're not sure and you simply wrote cofactor, boleh, ada satu markah. Kalau kamu tulis, what's the first one? Mineral ion kah? Metal ions. If you write metal ion, pun boleh. Kalau kamu tulis coenzyme pun boleh. Kalau kamu tulis prosthetic group pun boleh. Ini soalan yang umum lah, dia tidak perlu kamu bagi jawapan yang spesifik. Spesifik maksud saya kamu pergi Google apa bentuk sucrase, apa yang diperlukan. Don't need to do all that. Just simply write if it's cofactor, metal ion, or coenzyme, or prosthetic group. Mana-mana ini boleh terima satu markah. Okay, so we move on to question 1E. State the levels of protein structure that form enzyme. Anybody have an answer to this? Levels of protein structure. So ini dari yang primary, secondary, tertiary, quaternary. Marnie asked in the chat, tertiary ka? And Lim said tertiary structure. Okay, both of you are correct. It is tertiary. Some enzymes are also in their quaternary structure. Tapi biasa lah, anything that is tertiary or quaternary is accepted. Boleh dapat satu markah. And Intan is also correct. Good job. Cek kamu punya spelling juga ya. Okay, so this one should be fairly straightforward. No problems with it. All right. And we move on to the last part of this question, which is define the following terms in relation to enzymatic activity. So ini bagi definition ataupun explanation ringkas untuk active site, competitive inhibitor, dan non-competitive inhibitor. All right, very quickly, can somebody type their answers? Kamu mau type untuk tiga-tiga kah? Type untuk salah satu dalam chat pun boleh. Try to answer this in the chat. Or if you want to open your mic also can, that will be faster. Ooh, okay, we have answer from Claire for active site. Active site is a region on an enzyme that binds to other substance during a reaction. Almost correct. Almost correct. Kamu boleh cakap region, kamu boleh cakap site, tapi kamu tidak boleh cakap substance sahaja. Kamu patut guna keyword substrate. Okay, so almost correct, Claire, but you don't get the 1 mark. I'll write my answer here. A region or specific site on an enzyme that binds with substrate. Okay, good job though, Claire, thank you. All right, anybody to explain for competitive inhibitor? Competitive inhibitor is a molecule that what? Okay, Marnie has answered in the chat. If competitive inhibitors binds to active site, it will prevent binding of substrate. Okay. Bind to active site and prevent binding of substrate. Almost correct. Satu yang saya mau tambah pergi jawapan Marnie is I would add that has similar shape to substrate. Competitive inhibitor. So kalau saya improve jawapan Marnie lah ya, it will be competitive inhibitors have similar shape to substrate, binds to active site to prevent binding of substrate. Farah's answer in the chat is binding to the active site prevents substrate from occupying the sites and reduces the reaction rate. Almost correct, but I would give the same comment as I gave to Marnie as well. You should mention that it has similar shape. Okay, tapi hampir betul. Okay, very good, no problem. Okay, so I'm gonna write my answer here. Competitive inhibitor is a molecule with similar structure to substrate and can bind to active site to same active site. Boleh juga instead of can bind to the same active site, you can say it competes for the same active site. Competes for the same active sites. Ataupun apa-apa yang membawa maksud yang hampir sama lah. Okay, very good answers, Marnie and Farah. Thank you very much. And last question, non-competitive inhibitor. Ini lebih ringkas, ini tidak payah cakap dia punya bentuk. Any answers for non-competitive inhibitor? Okay, Marnie's answer changes the shape of enzyme, therefore it cannot bind to substrate. Idea itu ada, tapi itu lebih kepada effect rather than the proper definition for it. Okay, so Marnie, malangnya saya tidak dapat terima jawapan kamu sebab dia tiada keyword yang saya mau. Okay, Intan's answer, a compound that not compete with substrate for the same active site of enzyme. Almost, but not quite yet. It doesn't have the keyword that I want, but good try, Intan. Farahin's answer, substrate and inhibitor are not competing for the same active site of enzyme. Once again, concept is there, but not quite the keyword that I want. Syuhada punya jawapan pun non-competitive inhibitor is structurally different from a substrate molecule, does not compete with the substrate for the active site. Okay, same issue. The idea is there, dia tidak bersaing untuk active site. Jadi mana dia pergi? Terus cakap mana dia pergi. So my recommended answer is a non-competitive inhibitor is a molecule that binds to the allosteric site of enzyme. The keyword that I was looking for in your answers is allosteric site. Itu saja. Okay, I hope that is clear. But really good tries from Marnie, Intan, Farahin, and Syuhada. Thank you and good job. Okay, so begini. Oh, scheiße. Okay, beginilah dia punya jawapan untuk ini. Nanti saya akan post answer scheme di GC juga. So I hope that is clear. Any problems with question 1? Lim asks, no need to mention change the enzyme active site, right? If you want to mention it, can, but most importantly, you must have the term allosteric site. If you have the term allosteric site in your answer, and then belakang-belakang, you also add that it changes the enzyme active site, can, still correct. Cuma panjang sikit lah jawapan. Okay, thank you. Okay, so I'm moving on to the next. Oh yeah, more to effect, yeah. Okay, I'm moving on to the next question. Table 1 shows the rate of activity of an enzyme at different temperatures. So sekarang kalau kita tengok table 1 ini, di sini dia ada tunjukkan temperature in degree Celsius daripada kosong sampailah 60 degree Celsius. Dan di bawah dia, second row, it is the rate of reaction with the unit milligram per minute. Okay. So daripada kosong, rate of reaction is low. Suhu semakin naik, rate of reaction semakin meningkat. Bila dia sampai 40 darjah Celsius, rate of reaction dia 16 milligram per minute. Bila dia sampai 45, masih lagi 16 milligram per minute. Bila dia sampai 50, tiba-tiba turun secara mendadak menjadi 4 milligram per minute. Bila sampai 60, kosong sudah. Okay, so the graph is going to look more or less like this. Saya lukis di bawah lah terus ya. The graph for that is going to look more or less like this. It starts at 1, slowly go up, and then go down. Sampai kosong. It's gonna look something like that. So it will be temperature, with rate of reaction. Milligram per minute. Tidak perlu lah. So that is roughly what the graph will look like. Nanti kita tengok lagi macam mana mau tanda itu graph ya. For now, I go back to question 2A. State the optimum temperature for this enzyme. So, kita tengok saja pun, kita tahu, okay, between 40 and 45, somewhere in there is the optimum temperature. But we're not sure, is it 41 degrees, 42, 43, 44? So, to be safe, instead of naming a number, we just simply state the range. We state the range optimum temperature for this enzyme is between 40 degrees Celsius to 45 degrees Celsius. Part ni okay kan? Should be alright. Any questions for this before I move on? Okay. Right, then I'm moving on to question 2A. Explain the rate of enzyme activity at 15 degrees Celsius until 25 degrees Celsius. So soalan minta kamu explain kenapa rate of reaction di sini rendah. This is only 1 mark. Anybody have the answer to 2B? Oh, no. It's not kenapa dia rendah. Kenapa dia meningkat. Anyone? Oh, more collision between enzyme and substrate. Okay, Ken, parahin Ken. More collision between enzyme and substrate, just simply add to the end of your answer as temperature increases. Okay, so jawapan parahin boleh, which is more collision between enzyme and substrate as temperature increases. You can also write that rate of reaction increases as temperature increases. Both correct. Thank you very much. Very good job, Parahin. Okay, so like that, 1 mark. And then question 2C asks you to explain the rate of enzyme activity at temperature above 45 degrees Celsius. State the reason for your answer. Kenapa dia turun secara mendadak? Anybody can quickly answer this? Oh, when you're asked to explain, you can first state the trend. Yes, Marnie, correct. The enzymes become denatured. So enzymes become denatured at high temperatures. Tapi ini soalan yang 2 marka kan? I think you should have been taught this when you do English. You know that part with the essay and you have to look at the graph and then you have to explain what is happening in the graph. Usually you talk about the trend dulu kan kalau kamu buat essay English untuk muat tu. Yes, so you start by explaining the trend, which is what Lim wrote in the chat, rate of enzyme activity decrease. Marka pertama untuk soalan ini adalah nyatakan trend, rate of enzyme activity decreases, and then explain why that is the trend. The enzymes become denatured. Enzymes have reached its optimum temperature. Itu untuk explain apa yang berlaku di antara 40 degree Celsius hingga 45 degree Celsius. Jawapan optimum temperature tidak boleh digunakan untuk 2C sebab lebih tinggi daripada 45 degree Celsius, dia sudah mula untuk rosak. Dia mula denatured. Okay, so unfortunately, Intan, I cannot use your answer, but very good try. Mas Lim punya answer, cause denaturation of enzyme, correct. So that's the second mark. Mas punya jawapan, enzyme activity decreases, 1 mark, because enzyme denatured due to extreme temperature, second mark. Very good job. Okay, so boleh dapat konsep ini kan? Good job for this one. We go on to 2D, state 2 factors other than temperature which would affect the rate of enzyme activity. This one should be simple. Okay, Claire dengan lajunya dia jawab dalam chat, pH and enzyme concentration, very good. pH, enzyme concentration. Substrate concentration can also be the answer here. So mana-mana dua? So any two. I'm not sure if I mentioned this before or if other lecturers have mentioned it before. If the question is 2 marks, only give macam contoh soalan macam ni lah, dia cakap state 2 factors kan. So kalau soalan minta state 2 factors, sebaik-baiknya kamu tulis 2 sahajalah. Kalau kamu tulis 3, 2 betul tapi yang ketiga itu salah, kamu akan hilang markah, semua markah di bahagian itu. So just follow the question. If the question says state two factors, then you only need to state two factors. I'm telling you this because I'm not sure if your exam is going to be structure and essay or just objectives again. But, I'm just preparing just in case. Okay, so itu sahaja untuk 2D. Untuk 2E. Based on table 1, draw an appropriate graph. Dia minta draw appropriate graph. Okay, so I have to say another thing about questions. So, bergantung kepada soalan. Kalau soalan cakap draw, means graph kamu mestilah cantik. Kalau soalan cakap sketch, graph kamu bolehlah hodoh macam graph yang saya buat sekarang. But since it says draw, we have to do it properly. Alright, let's try this. Mari kita coba ya. Coba untuk draw appropriate graph, you need to take out your ruler or something. Does this thing have a ruler? I don't think it has a ruler. Okay, that's fine. I just have to try my best. Okay, masa kamu lukis, sila gunakan pembaris supaya lukisan kamu kemas dan tidak hodoh. So that means you have to write rate of reaction. Rate of reaction, jangan lupa dia punya unit, mg, milligram per minute. And the temperature, in degrees Celsius. Anytime that you are asked to draw a graph, remember to label your X and Y axis. Sama ada ini untuk eksperimen kah, untuk jawab soalan structure kah, ataupun secara umum, kalau kamu lukis graph, pastikan ada X-axis, Y-axis, ada label, dan lukis skala. So, skala di sini dia bermula dari 0. And then for temperature, we go up every 5 degrees, so 5, 10, excuse me, 15. Oh my gosh. Kalau tidak cukup ruang, boleh adjust. If you're doing this in exam, use pencil. 45, 50, 55, ke atas. Darn. 60. You have to write temperature. Oh my god. Ito. Pandai lang kamu. And then rate of reaction. Oh my goodness. 16. Why I do this? 18, 16, 14, 12. Oh my gosh, 10, 9, 8, 6, 4, 2. Pala na to. Ano pa na mo buat dito, P? Should start. My goodness. Isa po buat soalan ni. Okay, at 0 temperature, it should be 1. At 5, it should be 1.5. I don't like this. Yang penting antara 40 dengan 45 dia adalah macam ni. Dan lepas 50 dia turun pergi 4. Okay, your graph should look something like that. I hope your graph looks nicer than my graph. It's okay if it's ugly. How are we going to mark? You have correct curve. 1 mark. You have correct axis. 2nd mark. Okay, so ini bergantung kepada soalan. Di sini dia bilang draw. So kalau pemeriksa strict, dia akan sangat strict lah untuk macam mana saya lukis skala ini cantik ke tidak, saya punya curve. Tapi kalau pemeriksa itu dia macam chill sikit, then maybe graf yang hodoh macam ni pun boleh dapat 2 markah lah. Okay. Any questions for this? I hope this is clear. Okay, should be okay kan? Okay, then I move on with 2F. If the enzyme used in the experiment was maltase, name the substrate and the product. So for this one, we use the hack that I teach you earlier. Kalau ini adalah nama enzyme dia, kita ubah dia punya nama sedikit kepada O. The spelling of ASE change to OSE. Most likely you will get the substrate. So you'll have maltose. I'm sure you remember what maltose is. It is a simple sugar, a disaccharide. And if you remember what you learned in chapter 1 last semester, the product from breakdown of maltose will be 2 alpha glucose molecules. So substrate maltose 1 markah, product alpha glucose 1 markah lagi.
Miss, can I just say, for the product, can I just say glucose?
Can.
Okay, Miss.
Okay, begitu sajalah. So that is 10 marks, I think. From the first question, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nah, senang saja, 10 markah. Okay, then I move on to question 3. Siapa ni tulis ni tidak? Ini question 3 lah, sayang, ampun. Okay, figure 1. Yeah, who write this? Okay lah, boleh lah, figure 1. Figure 1 shows 3 different enzymatic reactions. A and B represent 2 types of inhibitors. So kita boleh nampak di sini. I'm going to use the highlight. I'm highlighting with blue the line without inhibitor. Okay. I'm highlighting with pink the line for A, inhibitor A. I'm highlighting with yellow the line for inhibitor B. State the type of inhibitor A and inhibitor B. Mana satu adalah competitive, mana satu adalah non-competitive. Anyone? Anybody? Okay, while you're thinking or typing, I'm gonna give a tip. For competitive inhibition, I like to see the C. So saya bayangkan kalau C, saya boleh buat hujung dia berjumpa. So kalau last rate of reaction hujung dia berjumpa, itu adalah competitive inhibitor. If you have other ways to remember, boleh juga. No problem. But this is how I remember lah. Kalau dia C, I imagine kalau ada 2 C, dia akan berjumpa di hujung. That's how I remember competitive inhibitor punya graph. Okay, so Shalini and Alice have answered in the chat. A is competitive inhibition and B is non-competitive inhibition. So those are correct. So good job. 2 marka. 1 marka untuk competitive inhibition, 1 marka untuk non-competitive. And then you have to give an example. So go ahead and write in the chat an example for competitive inhibitor and an example for non-competitive inhibitors. Any ideas? Oke, saya kasih cepat lah. Saya bagi jawaban lah ya untuk 3B. Example for competitive inhibitor is malonate. Okay, very good. Lim already answers malonate. Whereas for B, the example that I give you, I think should be isoleucine. I don't quite remember exactly what is the example I give in the lecture note, but isoleucine is an acceptable one. In my answer scheme, I also have the non-reversible inhibitors such as cyanide and heavy metals like mercury and also ATP. So ini adalah benda yang saya tidak nyatakan secara spesifik dalam lecture note tapi boleh diterima jugalah. Okay, answer scheme saya selain daripada isoleucine. Contoh lain untuk non-competitive inhibitor adalah cyanide, heavy metals such as mercury, and ATP. Okay, I move on. Next one. How do inhibitors A and B bind to the enzyme? This you just need to state whether it is allosteric site or the active site. So inhibitor A will bind to active site. Inhibitor B will bind to allosteric site. And then what happens to the rate of reaction with inhibitors A and B if the substrate concentration is increased? So ini kamu boleh tengok dalam graph juga. For 3D, you can see from the graph, what happens is substrate concentration increases. When you look at A, substrate concentration increase, rate of reaction increase. So we just write rate of reaction increases. For B, remains unchanged. Kita kasih naik macam mana pun, tambah berapa banyak substrate pun, rate of reaction remains unchanged. Biasakan guna term seperti remains unchanged rather than no effect. Ya, lebih suka guna remains unchanged lah. Jangan tulis no effect. Ayat begini lebih sesuai. Okay, so this very simple answer is already 8 marks daripada A, B, C, D. Pastikan kalau kamu jumpa soalan, kasih berani saja jawab. Any problems with this or with the concept of inhibition in general? Okay. Alright, itu saja untuk bahagian subjektif. Untuk bahagian essay, the essays for this chapter I find are a lot more simple. And the answers are mostly in the lecture notes anyway. So I hope you do try to answer them. Kalau macam contoh yang pertama ini kan, how enzyme can speed up the rate of reaction. Saya sudah bagi slide. Dalam slide tu ngam-ngam 5 ayat. Guna saja 5 ayat tu boleh dapat 5 markah. And then after you're done, you can use the answer scheme, which I will post in the GC, to mark your own answers. And you will be able to see how well you did. For 1B, explain how enzymes are denatured by high temperature. Ini pun senang juga untuk mau jawab. I think when you see this, of course, the first word you're going to think of is denature. But I would encourage you to explain a little bit more if it is essay. Soalan essay ini lama juga sudah bahkan kamu tidak buat essay. Jadi saya kasih tahu sajalah tips sikit. Untuk soalan essay, kamu explain sejak daripada konsep yang asas pasal topik itu. So contoh, if I want to explain how enzymes are denatured by high temperature, I start by saying that enzymes are globular proteins. Globular proteins means they are held together by this bond, van der Waals interactions, hydrophobic bonds, disulfide bridge, etc., etc. At high temperature, these bonds will be broken, enzymes will be denatured and change shape. Okay, so bila saya explain dari awal sampai akhir begitu, baru saya boleh dapat 5 markah. And for question 2, name and briefly explain the classes of enzymes according to IUB classification system. 10 markah. We have 6 classes of enzymes, right? So you name the 6 classes and just the definition or the 1-sentence explanation for each, you can already get more than 10 marks. But kept at 10 marks. Begitu sajalah, sangat simple dia punya konsep untuk chapter ini. So untuk chapter ini saya tidak akan explain banyak lah. Kalau kamu ulang balik lagi bahagian chapter ini nanti and you want to ask questions, feel free to do so. But yeah, it's very simple, very short one. I hope that it has been a little bit easier for you. Okay kah? Boleh? Okay, then I will stop presenting this. Okay, thank you very much. How do I stop presenting? Shoot. How do I stop presenting? Oh, okay, that does it. Okay. All right. Nice. Okay, so itu saja untuk discussion kita untuk tutorial. Saya mau relate sikit kepada eksperimen yang saya minta kamu tengok semalam. So for yesterday's lesson slot, I asked you to watch the video demonstration for experiment 9, biocatalysis. And then I asked you to answer a Google form with some understanding to the concept and some data for you to interpret and also answer. Do you have any questions regarding that experiment or regarding the Google form? Setakat ni ada 41 response sahajalah.
Miss, actually that we need to do the experiment during the hybrid class, right?
I'm not sure when are we if we are even going to do this experiment. So, okay, there's a few things to consider. Kalau tiada case ataupun case sangat rendah di college dan kita boleh face to face, of course you would have done this experiment. Oh no, you would do this experiment after mid-sem break. Tapi sebab sekarang kita di label cluster dengan tidak tahu bila dapat face to face, bila kita dapat face to face mungkin sangat limited masa kita. So kita akan fokus kepada eksperimen chromatografi. After that, it also depends lab technician dapat cari itu hati ke tidak. So not sure if we will do this experiment face to face or not. But for now, this unfortunately is how you learn it lah. Okay, something is up with my Google Meet today. It's not functioning very well. I think I need to give my computer a break after this. Ada masalah ka dengan eksperimen itu? Ataupun kurang faham? Can't share my screen, scheiße. Okay, I cannot share my screen. Tidak banyak juga lah saya mau explain daripada eksperimen itu. Just that if you did do the experiment when we put in the H2SO4, it's supposed to stop the reaction. So when you use the red KMNO4 solution and you shake to see, you're actually checking how much hydrogen peroxide is still remaining in the solution. So macam kita tengok berapa banyak baki substrate lah dalam bahan itu. Dan berdasarkan maklumat yang kita dapat daripada eksperimen, kita boleh kira approximate rate of reaction. Okay, if there are no questions about it, then I'll just finish it there since I cannot show the screen and I cannot explain without the screen. What else do I need to tell you about? Oh, if you can open with your laptop, this will work best. In the GC, I shared a link to a simulation. So, untuk simulation itu, kamu boleh manipulate concentration of enzyme, concentration of substrate, presence of inhibitors, temperature, pH, dan sebagainya untuk tengok macam mana molekul-molekul tersebut bergerak dalam sesuatu ruang. So if you have a laptop, that's very good. If not, if you're using your phone, you may need to change the display to the desktop setting. Ataupun paling senang, pinjam saja kawan yang ada screen lebih besar. Roommate pun jadilah, walaupun dia tidak ambil bio. You just need to have the link. Okay, itu saja. Oh, the thing that I wanted to say is there is now the e-assessment of lecturers. Ada borang e-penilaian pensyarah. Untuk unit bio, ini adalah link dia. I've sent it in the chat. So, I need your help to please fill in this EPP as soon as possible. Kalau boleh hari ini terus isi, bagus. Kalau tidak, weekend inilah ataupun hari Isnin. I won't know your name, exactly what you say. Pensyarah lain yang akan tengok feedback kamu. If you want to give feedback about me, feel free, go ahead and do that in the Google form. If you would rather give me feedback directly, that would be helpful as well, and I am happy to receive that. Don't worry, I don't yell at you, so no need to be scared, but do tell me if there's things I can improve in my lesson. Semua okay?
Okay, Miss.
All right.
Okay, Miss.
Thank you, Akila. Thank you, Farahin. Thank you, Eva. Thank you, Marnie. All right, then. Thank you, Presley. I think next week we can go into chapter 5. begitu sajalah untuk minggu ini. Thank you very much for your time and your attention. After this, make sure that you finish answering the Google form for chapter 4. The link should be in GC. Do the Google form from yesterday, the one with the experiment 9. Finish marking your own tutorial and then submit in GC. After you get your assignment draft back, you can work on the final work and then submit in GC. I'm going to open the submission slot after this Google Meet. Dan yang belum dapat assignment draft, jangan risau, saya akan kasih balik. Kalau saya lambat kasih balik, saya akan bagi kamu extension. Okay. We're cool? We're good? Okay, once again, thank you very much for your time and your attention. That is the end of today's class, and I will see you again next week. Bye. Bye-bye.
Thank you, Miss.
Miss.
Thank you, Miss.
Thank you, Miss.
Thank you.
Miss.